it's 4 p.m. According to the schedule, this is the slot where I'm supposed to have this session. So welcome, everybody. This is a session about building your own PowerShell predictors. And as you can probably tell, there's no PowerPoint involved. I tried to make sure that this whole presentation will not be touching any PowerPoint at all. I also have to shamelessly plug in with my my eldest daughter work. So any pictures you will see on the screen today, all of them are just created for me by her, which makes it so much easier to not worry about any licensing. And she's pretty cheap, so it's, I decided to go with it. So yeah, first few words about sponsors. Thank you very much to all the sponsors. They are a reason why we are here, or maybe because of their involvement, we can be here. We are here because you want to listen about PowerShell. A few words about me. My name is Bartosz Bielawski. I'm originally from Poland. Currently I'm living in the Netherlands. I work for Optiver. I go by with my handle BLB anywhere I go, so you can find me under this handle on Twitter. You can find me on the same handle on the GitHub. So any work I do, you will probably find under that. And if you want to reach out, you can use Twitter, obviously, but you can also reach me out over email. You have email on the screen if you want to take a picture. That's the moment. If you don't want to take a picture now, you can ask me later, no problem. It's not like I'm going to run away after the session. So plan for today. First, I'm going to start by slowly just explaining what the predictors really are and some limitations to the tool. Then I will just drop a few ideas I had when I last year during this conference, I heard about them. I immediately sparked some ideas. Some ideas came later, some ideas came right away. And then I will just dive into the VS Studio Code and just build with you on the stage predictors, what could possibly go wrong. So, what are predictors? So, PowerShell PS readline allows you to predict what you're going to type. And if you're running PowerShell, Windows PowerShell 5.1, you can take advantage of that feature. The problem is that there you can only rely on the history. So only your history is accessible as a way of predicting your future lines. When you are on PowerShell 7, however, you can have additional sources of your predictions. And last year, Steven, who's over back in the room, was presenting it using Azure. I couldn't take it home because I don't do anything with the cloud. My company is on-prem mainly, so that didn't really sit well with me, didn't help me much. But there are some other examples that he gave, like, for example, the fact that you can predict tab completion results. So let's just try to look at that. So if I import completion predictor, you can already see that something is going on with my prompt when I start typing things. So if I try to run get child item and I specify the dash, it immediately gives me the potential tab completion results, which are in turn presented as in this list view as an option I can select from. And then when I select one of them, I can take it from there and just move on, right? Which is very handy. So I was looking at that, and my brain started to just, process the different ideas. And the first thing that came to my head is like, okay, what if I have this module, and I worked hard to make sure that any command that I have in this module has help. And next to the help, it actually has some examples. What benefit it gives you to any user that starts working with this module is that if they don't know anything about commands that exist in this module, I can help them by providing all those examples. So whenever they try to just look at my commands in my module, they will be able to take advantage of that. And that's how the AWS predictors came about. The way it works is basically I have some examples for things from my module. As you can see now on the screen, we have multiple commands coming from this module, and I predict that you want to run one of those commands. So whenever you specify one of the commands that exist in this module or part of the name, I will just filter out of all the help that I have and kind of present you that as an option for what the line that you maybe want to run. It's not perfect, because if I would do something like get AWS folder, which is nice, and then I pipe it to something else, the prediction will be starting over. So if I do that, because you can see, just wipes the whole line. So there's plenty of work to do before it actually makes its production ready. But at least if you don't use pipeline, which you probably should, it gives you at least some ideas of like how you can run, how you can use these commands and in the PowerShell. So that's what I wanted to highlight here, that PowerShell predictors are a feature that work for both in 5.1 and PowerShell 7. But if you really want to take full advantage of this feature, and especially the talk that I'm going to present here today, most of it, like all of it actually, is going to be relying on building predictors, and that you can only do when you target PowerShell 7. So if you're stuck on PowerShell 5.1, I'm sorry, it's not going to help you much, because you're not going to be able to take advantage of whatever we're going to produce here. So you can use AWS module in PowerShell 5.1, but you will not get any predictions in it, because unless you were running all those commands and you already have it in history, obviously. So ideas, I mentioned two ideas. So module examples, I already kind of went through that a little bit. Another thing that came about is like, okay, you have the history in PowerShell 5 and 7, right? But what happens when a junior member of the team that doesn't use PowerShell very often starts working with the history? His history is empty. He doesn't have any history of using PowerShell. But maybe your history has a lot of useful commands that you run before, that maybe if he would have in his fake history, he would be able to take advantage of PowerShell more, because you can use that as a way to share your experience, the way you can take advantage of PowerShell with the rest of the team. And initially I was thinking, it would be great if I can make that in a REST API and just let PowerShell call REST APIs in the runtime, and everything will be great. It wasn't. It didn't work at all. I didn't understand why, and I found out this morning that PowerShell predictors, the way they define right now, they have strict limit of 20 milliseconds, and after 20 milliseconds they give up. And I didn't manage to produce any REST API that would result in the response within 20 milliseconds. So I ended up with just having a static list of commands in the file, and that's what we're going to build actually today. So you can see that I have this other idea, GPT AI, and that's what Azure actually is doing, is using some AI. The good thing, the reason why it works for them and it doesn't work for me, is because they are smarter than me and they actually cache those results. I didn't figure out a way yet how to just call the AI and they get results and then cache it, and then whenever you ask for it, I give you a response within 20 milliseconds, because everything is cached locally. Therefore, I can fit within those 20 milliseconds. So that's the ideas. Now for the meat of this presentation. So we're going to start building our predictor in Visual Studio Code. So let's switch to the VS Code. By the way, before you start doing it yourself at home, I strongly recommend that you use this page, how to create a command line predictor. This is very good documentation. This is the only resource I used to start with building my predictors. I still don't understand some parts of the code, and I'm going to get to that later and then explain, probably just explain why I didn't really spend too much time on that part of the code. But there are some things I already changed and decided, okay, I want to do it differently. That doesn't change the fact that if you go through this documentation, you should be able to kickstart your project. And with this presentation today, I will kind of walk through the steps here and also show you how that looks in the real life, so we can maybe encourage you to try the same, to show you how simple it is. Because if you look at the page, it doesn't matter how long documentation is. We as IT people, we don't like to read documentation. We like to see things. We like to do things. And and then the result is that we don't do those things because we didn't read documentation. So I want to present this to you so that you actually encouraged to try it at home. It's not that scary. So if we go for this one, so first thing we need to do is install tooling. So in order to use any of that, you will need to install .NET SDK, not runtime, .NET SDK, because you need to be able to build your code. It's in the documentation as well. I will just show you that I have SDK here. So if you run .NET -list SDKs, it will show you a list of SDKs that you currently have on your machine. If you have 6 point something, you should be good to go. Next, the idea is that you want to build a class, you want to build a project, and for that, what the page suggests is just to run another .NET command that will just create the basically skeleton for your project and skeleton for your class, and you go your merry way. I'm not going to do it like this because I'm not that crazy. So let's go back. Let's remove all this, and instead let's switch to branch where I already have some skeleton that's ready for that demo. So now, whoever was in the session that I did on Monday, you can probably see I mentioned that the prompt is very useful. You can see already here as well. I did list SDKs to see which SDKs I have, but in the Powerline, actually, this is not Powerline actually, but in the prompt now, I can see which SDK version I actually have, which is very handy when you are doing some C# coding in a VS Code or anywhere actually. So this is just empty class. So let's go to the folder where we actually have it. I think I'm already there. Okay, yeah, I'm already there. Awesome. So let's just open the files that were kind of produced for us. The first one I didn't touch at all, so that's the way it was defined by the command, the .NET new. I did change that one a little bit. I just renamed namespace to something I want to have. I added this class demo predictor. It's not nothing that will predict any of your code. It's not that. So next step that the team suggests is to well, basically just copy paste the code that we have in our example, right? So again, I'm not gonna pretend like I know how to use a mouse. So now we have the code changed, and this one changed for now only. So because we're gonna use the PowerShell SDK, we need to include that in our project definition. That will tell PowerShell, .NET build command that it actually has to restore this SDK in order to be able to use the classes, the namespaces that are used in the predictor. Next step, let's see like the difference. So as I mentioned, is just adding this thing, and now we're gonna define. Oops, sorry, something went wrong here. Let's get out of this. So now we're gonna define our predictors. So define predictors. So I think I'm missing a step here. Yeah, that one. No. Oh yeah. Okay. Sorry. So this is basically what I did here is pretty much just copy pasted the example that was on the page. Nothing else happens here. And you can see here already some important things. First of all, we are importing and we are using few namespaces that were not used normally. One of them is System Management Automation Subsystem Prediction, which contains the interface for any class that you want to define as a predictor. And a few other namespaces that are also useful for the rest of the code. So we define our class, the demo predictor. We did again, we're gonna implement the interface iCommand predictor. We need our GUID because it will be useful to kind of distinguish that one from other predictors that may exist. This one is pretty important because if you the name you provide here, it's the one that will be shown in the list view later. So you probably want to make that easy to distinguish from other predictors that you might have. So if you call it history here, you will be confusing your users a lot. I don't think description is used anywhere. And the meat of it is actually happening in this suggestion package, the get suggestion method. So that's where the implementation goes. That's the only part, except for the constructor that I touched. There are some other things below that, and I haven't really read documentation, as I mentioned, so I don't know what they do. So I'm not going to pretend like I understand what they do, but they are not necessary for this purpose, right? So in this case, we don't really need to understand what they do, and we can still get our results as we would expect them to. So yeah, there are a few methods here, and I suspect that once I read documentation, and you can see that the commands here provided are documenting it pretty well and tell you what is what and how you can use it potentially. Yeah, so we're not going to touch that. And one thing that's also important, you have this initialization, which is going to be, it's pretty much, this DLL that we're going to build is going to be a behave or going to be a PowerShell module, binary PowerShell module. And for that to work, you probably want to have unique identifier for your module. So make sure to modify that. So don't leave it as it is from the example. Try to put any new GUID. I mean, it's not that hard in PowerShell. You just run new GUID.GUID, and then you get the GUID. So you just copy paste that. So it's pretty straightforward. And as you can see, then on import, it will register itself in the subsystem as a command predictor. And when you remove the module, it will remove itself. So that's pretty much it, right? That's all this thing is doing, is pretty much just making sure that you get there, you register yourself, and then you just start predicting the results for a user. Okay, so now we have a skeleton. We have this the module, but there's something still missing. So we will need somewhere to distribute or import that module, right? I mean, importing DLLs is not that great because, well, for me personally, any module should have manifest. And if I want to publish in the gallery, it's actually mandatory, right? So next thing I'm going to do is I'm going to create a folder which has, yeah, I need to check out. I think, no, this is the problem. The thing ordering here is kind of off. So yeah, I have my manifest, and in that one, I just define my version, define outer, define all those fields that are required for later to be distributed. And as you can see here, I also specify the version of PowerShell, and it's pretty important for the modules that are going to implement those predictors, because you don't want to have a situation when somebody with PowerShell 5.1 will install them and expect them to work, because they're not going to work there. So that's our PSD1 file. But that's still not good enough, right? Because we have our code, but we still want to build it. And that's a nice thing about VS Studio Code, is that within it, we can easily build our modules. So let's check out the branch that actually has necessary tools. Let's open one of them. So how many of you are using the build functionality in Visual Studio already? Visual Studio Code, sorry. Yeah, so you probably know those files, the launch.json and task.json, that allow you to, in .vs Code, to pretty much tell what you should do when you press F5. If not, I strongly recommend reading about it because it's really handy. And the interesting thing about this one, if you want to debug it, it's DLL that is going to behave like a PowerShell module. So instead of running it, because you cannot rerun it, you would need to do something like I'm doing here. So I'm just calling PowerShell.exe, and I'm telling it to no exit, no profile, and I'm telling it to import my module, pretty much, right? It's useful that we have this workspace folder variable that allows it to just make sure that we actually run it in this proper folder where we actually build our stuff. And the good thing about this is that, okay, now we have our module, we will import it, and we'll be able to debug it, and I will show you in a minute how that works. Next to that, I'm relying on this copy DLL task, and there are probably better ways to do that, but I'm not smart enough to kind of figure it out, so I decided to just go the easy way. So I have a task which actually copies DLL that I produced from the build task, and then another task is actually going to build DLL for me, and that way I just have to rely on this copy DLL, which will just copy DLL that other one that I depend on, just build it. So it's like kind of like a chain of dependencies that results in this fact that when I press F5, it builds the new fresh DLL for me, and then copy it to the location where I expect it to be, and then I import the module, and I can start debugging it. So let's try it. It's going to press F5. Let's maybe make it slightly bigger so that list view works for those of us that actually like it. Okay, so I just have this example code, right? So I tweaked it a little bit. In original, it was just, I think it was adding hello to the any line you would type. I decided to make it slightly more suited for this conference. But that's pretty much what the example is doing. Not very useful, but at least it gives you an idea how you can interact with whatever person is typing. So if I say echo and I complete it, and if I switch to list view, you can see that I have something from my history, and there's, as I mentioned, there's this demo predictor that has the line that we actually just produced based on the input from the user. So I can press enter, and I made a typo, and it doesn't work, but you get the point. So yeah, that's nice, but that's definitely not what we're aiming for, right? We didn't want to append hello PSConf to every line that user would type. That's not very useful. Let's go back to editor. So next thing I'm going to do is switch to the branch where we kind of have it. Oh, sorry, I just forgot to exit the debugger. We're still here. We need to stop it. So now we can switch branches because it's actually going to know what to do with it. So making it work, which is awesome. So yes, I did switch to different branch. Code changed a little bit. I'm not going to show you how just yet. Let's first see how it works, right? So let's just press F5, build it again. All the tasks that I had defined in the tasks.json and launch.json are now called. And if I go back to console, let's go make it bigger again and switch to terminal. So now I'm starting to type. And yeah, if I just use the regular view, it's this. If I use this one, then I get something completely different. Again, it's not literally like a shared history yet, but you get the point, right? So now I can just make sure that the list of text that I'm sharing is actually something useful, and that's going to be that. Before we go, therefore, let's just make sure that maybe stop debugger. I can show you that it's possible to debug this code. So let's go to the CS file, and we know that the method that will do most of the work is here. So we can maybe put a breakpoint somewhere here. And now if we just F5 again, it will build itself again, go through the whole process. And if we switch to terminal, we can start typing. And then it immediately goes to this debug. And now I can see what I have as my disposal, which is useful when you really want to start building those predictors in a way that you think that are useful. So the most important thing here is this context, because that will give you all the information about where your cursor is positioned, the whole input IST. You can see the code token and the cursor, so you can see where in the line you actually are. Using AST means that you have a lot of visibility into what person just typed in the console before you start doing anything with what they might want to do it in the end. What I'm missing here is information about the status of the shell or execution context of the person that is running it. I have no visibility into that. So for example, I cannot ask it, what modules do you have? Or what, because I was thinking maybe another idea I had, maybe I can just, if somebody types alias, I can just immediately propose, okay, maybe you want to have a full command. But it's not possible because I cannot see aliases, because I cannot go into your execution context. I can make assumption that you will have this alias, but I cannot be sure that you actually have it. But yeah, this is so this is pretty much how we can walk through it. Obviously, all those usual tools that you would expect work. So now we can see, okay, the input was A. I can walk through that and then see how that works. I can just go through all those code samples that I have, figure out, okay, why it's actually giving me this Chuck Norris crap instead of the actual thing that I wanted to see here. All those things are possible. How does it do those things? So I mentioned that I modified 2 methods here, and the first one is constructor. So the constructor for this class now will basically just find code samples.txt file in the same folder where the DLL is located, read it through, and each line in this file will become a potential suggestion. So I just store it in the read-only variable. So once the constructor is finished, it's already there waiting for me, which explains why this 20 millisecond limit was not a problem in this case. I have it in memory, so it's pretty fast to get those lines back. So the only thing I'm doing in my predictor in the end is just, okay, I'm reading your line, and I'm just checking if the line that the person typed in is contained within the line that I have in my fake history, right? So whenever they type something that is in the file, they will get the list of those suggestions back. Pretty useful, but again, pretty fast, therefore it works. So let's just do one more change. So it's going to work better now. Let's build it first. And now that we finished building, we can debug it again. I'm not going to do it here because I really want to show you the result. So now I have this module imported, and let's say I know that there's this command that is doing something with DSC. Okay, let's switch to list view because it's so much easier to see there. So now you can see that I have, start DSC configuration. Oh yeah, that's the command I can use to start DSC configuration on my server. So as a junior, you only have to remember, okay, Bartek told me I have to do something with DSC. Okay, let's type DSC in the console and see what happens. And then you can scroll down, you can select this one, use Alt-A to select your server. You change your server to something that is actually useful, CMP01, whatever the naming convention in your organization is. You can run it. I'm not going to run it now. Obviously, it will fail, but you get the point. Another example, I'm not sure how many of you know exactly how to use XPath to get information from WinEvent command. Yes, a lot of you guys. Well, that's my expected result, right? Most of the people don't know how to use it, and therefore they are not using it at all. They prefer to show event log and just filter there, and they are happy with this. But what if there was a way to show everybody how you can actually take advantage of these filters? So get WinEvent, and there you go. I have my sample, and it's my sample, so I know it works. I can give it to you. Then you run it this one, and then maybe you want to tweak it a little bit. Maybe you want to change the event ID, or you want to change the event data, or whatever. You see the example, therefore you can learn from there. and take advantage of the commands that you probably didn't use before because you didn't have enough exposure, enough experience with them, and immediately get up to speed with that. All thanks to the predictors, because they will just kind of help you to guide you through this. So yeah, if I just do something like A, you can see that there's some mixture of the history commands, and there's like this completely made up command that I just added just to, because the demos are hard and making stuff up is even harder. But there are some like set DBA owner. We also use that very often to just like modify the owner of the database. If you don't remember the syntax for this command, I can just give you that in my history, shared history for everybody, and everybody can take advantage of that. The only limitation, you have to be on PowerShell 7 in order to take advantage of this, which might be a limiting factor for a lot of organizations. It definitely is for mine, so we didn't do that yet, but that's definitely the plan. Okay. Any questions? Go ahead.
Currently, you're showing samples or examples which you provided in a text file.
Yeah.
Is there a way that you can provide extra input to that file based on what you've done?
So the question is, currently it's just static file. Is there a way to expand this file based on what you did before? I mean, if you did it before, you will get it by default from the history itself. But I think it definitely doesn't harm to either make it an easy way to just like, yeah, this file is, for example, downloaded when you start the session, and you put it on some central location, so then you don't have the caching problem, right? The constructor can also like run a REST API call, because it's only called once, so then you also don't have this 20 milliseconds. I didn't know why any of my REST attempts failed. Now that I know it, probably I will come up with some ideas like this. But yeah, indeed, it will be handy if you can just expand on it without modifying module every time, because that's going to be a nightmare to just, oh, I want to add another command, so therefore I have to create PR for it. It doesn't feel like it's a great idea. So yeah, I think that's just another step, is just to make sure that you can actually just actively expand on it, and just make sure that your constructor is actually doing all the work for you. The alternative to have async calls somewhere that will just sync it and cache it, it's kind of above my pay grade, and it's not the level I would rather go at this point, but it's another option, right? So if you are smart enough to use those things, and maybe you want to take advantage of like what Azure team did, look at their code and figure out how they did it. I tried and I just gave up. Any other questions? Well, if there are no other questions, I actually, that's what I prepared for today. So what I wanted to give you, and what I would like to take home from this session, is that, first of all, if you are not bound to PowerShell 5.1 and you can use PowerShell 7, I really recommend you start taking advantage of the predictors and just building. If you don't want to even build your own predictors, moving to PowerShell 7 will make sure that you can use work from others. If you look at the repository, the PowerShell gallery, there are plenty of modules already that, at least based on the name, seem to be implementing predictors. So you can already start taking advantage of that. And regardless if you like list view or just regular view, you can use it. Improve your productivity with it. And as you can see, the building your own predictors is not that hard. It took us, well, too little time to actually to fit in 45 minutes. But we were able to do that here on stage, and it didn't require a lot of coding. So even if you are not C# developer, I'm not, you can definitely do it yourself. And you don't have to install Visual Studio, because C# coding in VS Code for that kind of project is definitely more than enough. You can definitely survive with it. And future plans is definitely, like, for me personally, what we spoke with Robert. So coming up with ideas how to make the whole thing be more dynamic and make sure that it actually works for the scenarios that I came up with. So that's one thing. Second thing is just going through those additional methods that I didn't touch yet. They sound interesting, but I didn't have an idea how to actually start using them in my own code. And this, the third thing is just to like make sure that any product of that is available for community. Because I had this, I mentioned that I have this AWS predictor for my help for my module, but I think it shouldn't be that hard to convert it in some kind of like global thing that you can just take this whole code, take your help file, because I'm just using the XML files, I'm just passing them, and then just have your examples also exposed as this predictors. And obviously, if that's going to happen, I need to figure out how to make sure that the pipeline is not breaking and everything, right? So thank you very much for joining this session. Well, I leave you a bit more time for coffee. I was not expecting that it's going to go so smooth. So I left some time for on-stage debugging. That didn't happen. Sorry. No fun for you. Less stress for me. So enjoy the rest of the conference, and thank you.